we've been talking about the basics of a polygon and triangle, and this video is all about the four-sided shape that is called the quadrilaterals. So in this video, first of all, I'm going to talk about the types of all the different quadrilaterals, and then now we focus on each quadrilaterals in terms of the size and angles and lines of symmetry and rotational symmetry. Now look at these shapes. So these are all different quadrilaterals, and pause the video and quickly tell me the names of the quadrilateral. Good job. So now first one is square, and the next one is rectangle and parallelograms and trapezium. Then we have a rhombus, and then final one is a kite. So now let's talk about all details of these quadrilaterals. Now let's talk about the sides and angles of these quadrilaterals. First of all, square. So we all know that square has got all equal sides and all equal angles as it's a regular four-sided shape, right? And now let's focus on the parallel sides. As you can see, it has got two pairs of parallel sides. The parallel side, when you extend the two sides, it never meets, right? So these are called the parallel sides. Alright, let's have a look at the rectangle. Rectangle has got two pairs of equal sides. Can you see the red and blue one? That it also has got two pairs of parallel sides. And then you notice that all the angles are 90 degrees as a right angle. Then let's move on to the rhombus. Rhombus is important because it has got all equal sides, but angles are different. So opposite sides are parallel. So it has got two pairs of opposite sides, and the opposite angles are equal, and four equal sides. That is the main characteristics of rhombus. Then parallelogram. Parallelogram is important because it has got two pairs of equal sides. Then you notice that the opposite sides are the same size. The lengths of the opposite sides, are same, and the opposite angles are the same as well. Then now trapezium it has got one main feature, that is only one pair of parallel sides. Then kite. Then have a look at the kite. The important thing about kite is it doesn't have any parallel sides. But as you can see, the blue and green line, it has got two pairs of equal sides. Adjacent sides are the equal. Then no pair of parallel sides. And then can you see the red angles? One pair of angles are the equal as well. Right, so have a look at the more quadrilaterals. Trapeziums, can you see that we have isosceles trapezium? This shape is a trapezium since it has only one pair of parallel lines. But as you can see, two sides are equal and two angles are equal. That's why this is called the isosceles trapezium. Then we also have another quadrilateral that is called the delta. Looks like arrowhead, right? And then finally, I also have an irregular quadrilateral as well. We are going to talk about the lines of symmetry. Lines of symmetry is one of the important characteristics of the quadrilateral, and then we use a mirror line to work out how many lines of symmetry each quadrilateral has. So we all know that lines of symmetry, right? So let's have a look at the square. How many lines of symmetry can you see? So first of all, we can see the diagonals of a quadrilateral can be the lines of symmetry, and then we can see horizontal and vertical lines. Square has got four lines of symmetry, right? Let's have a look at the rectangle. Rectangle has got how many symmetry lines can you see? It has got only two symmetry lines, that is a horizontal and the vertical lines, and then diagonals are not the lines of symmetry. When you fold it alongside with the diagonals, both sides are not the same, right? Then now, what about the trapezium? Isosceles trapezium has got only one line of symmetry, and the other trapeziums, there's no line of symmetry. How about kite? Kite has a one line of symmetry that just goes through the middle, right? Then rhombus. Rhombus has got a diagonals. And you know what is diagonals? Diagonals means when you have opposite vertices and when you connect them together, that is called the diagonals, right? So two diagonals are lines of symmetry, but not the horizontal or vertical lines. Then parallelogram has got zero line of symmetry. Then delta has got one line of symmetry. And as you already know that irregular quadrilateral, there's no symmetry line. Now this time, let's talk about the diagonals in the quadrilateral. I already told you that diagonals means when you have two opposite vertices and you connect them together, these are called diagonals. And then we specifically focus on the bisect. So bisect means that it divides into two equal parts. We need to think about the diagonals bisect the shape or not. So square has got two diagonals and these bisect each other. That means two parts of the square has got a same area. Then the diagonals, they meet at right angle, perpendicular lines, right? Then let's have a look at the rectangle. The diagonals of a rectangle, they are not the perpendicular lines. As you can see, it's not meeting at the right degree, right? And then, but it still bisect the two parts. The area of two parts is exactly the same. Then isosceles trapezium. So trapezium diagonals, they do not bisect the parts and then they do not meet at right angle. Kite diagonals, they have perpendicular lines. It's meeting at the right angle, but one of the diagonal bisect, but the other one is not. So that's why I do not bisect. And how about rhombus? Importantly, the diagonals of rhombus, they cross at 90 degrees. These are the perpendicular line. Then it also bisects the shape. And then parallelogram, but as you can see, it's not perpendicular lines, but it's bisect. Then delta has got very special diagonals. Since you connect the opposite vertices, you've got diagonals outside of the shape, and it's not bisect. And you can see these diagonals are perpendicular line. Then irregular quadrilateral, no perpendicular line, and then do not bisect. Now let's talk about the rotational symmetry. So rotational symmetry means when you turn the shapes around the center point, a full turn, that you need to think about how many times the shape fit exactly on itself. This is called the rotational symmetry. That now our center point is the center of a rotation is the intersection of the diagonals. That now I'm going to spin around the shape full turn. Then please count how many times the shape is exactly fit into the original shape. So first of all, let's spin around the square along by the center of rotation. Then please count how many times you can see. 1, 2, 3, 4. So when the square spin around the full turn, we saw that 4 times the shape fit exactly on itself, right? So that's why it has got 4 rotation symmetry, all the 4. Now let's have a look at the rotation symmetry of a rectangle. Now I spin around. 1, 2. So as you can see, every half turn the shape fit exactly on itself, right? That's why the rotational symmetry of rectangle is 2. We can say order 2. Then how about the trapezium? A spin around. So in that case, we couldn't see the rotation symmetry, right? So we can say no rotation symmetry, and the other trapezium as well doesn't have so it's no rotation symmetry as well. How about kite? So spin around it, full turn, and then we couldn't see that the shape is not fit exactly on itself, so that's why it's no rotation symmetry. When it comes to no rotation symmetry, we say order 1. Then now this time rhombus, let's count 1, 2. So every half turn it exactly fit into the original shape, right? That's why it has got 2 rotation symmetry. We can say order 2. Then parallelogram. Let's spin around the parallelogram. 1, 2. Parallelogram as well. Every half turn we can see the rotation symmetry. That's why it has got a 2 rotation symmetry, order 2. Then the delta has got a no rotation symmetry, so we can say order 1, and the irregular quadrilateral also hasn't got any rotation symmetry, so it's order 1 as well. Now we've been talking about all the details of the quadrilaterals. Then this time I'm going to divide the quadrilaterals into different categories. So I'm going to group the quadrilateral into how many parallel sides they have. So first of all, quadrilaterals with 1 pair of parallel sides, and then quadrilaterals with 2 pairs of parallel sides and no parallel sides. I think you can remember all of the different quadrilaterals in terms of these parallel lines, right? So first of all, what quadrilateral has got only 1 pair of parallel sides? That is trapezium, right? Then now let's focus on the quadrilateral with no parallel sides. Exactly, it's kite. And then importantly, quadrilaterals with 2 pairs of parallel sides is called the parallelogram. So all the quadrilaterals that has got 2 pairs of parallel sides are called the parallelograms. So underneath the parallelogram, we've got very special types of parallelograms. For example, the parallelograms with the 4 equal sides called the rhombus. Then we have another special parallelograms that has got right angles. So parallelograms with the right angle is called the rectangles. And then finally, for right angles and 4 equal sides are called the squares. So these shapes are all same group. So these quadrilaterals are all same group. This is called the parallelogram group. So we can say rhombus is a parallelogram, square is a parallelogram, and rectangle is a parallelogram. Okay? Okay, now let's try to solve this question by using all the knowledges about our quadrilaterals. This one, you've got a quadrilaterals, then read the statement, then you need to think about that statement is it true for all or some or no. Okay, so first statement, all 4 sides are the same length. Is this the same for